Okay. Defensive, offensive, robot security.
All right. Does this work? It does.
Nice. Okay.
Right. Thank you.
Please.
All right. Good afternoon, everyone. First of all, thanks for having us. Thanks, Bjorn, for introducing, and thanks, Thilo, and everyone for, I think, a pretty cool event. It's the second year in a row I have the chance to speak here, and it's very pleasing to see more and more industrial players involved. So great stuff going on. Alias is a robot cybersecurity company. We essentially work with manufacturers of robots and also users and try to make sure that these technologies are used securely. Security has typically two facets, the offensive and the defensive one. Let's start with the later. So typically when we think about security, and particularly within this context, we tend to isolate ourselves into the upper layers of this representation. This has in the middle the OSI stack, and how approximately, please bear with me, we can understand the different layers of ROS and ROS2. Now, according to statistics, most of these security attacks actually happen at layers 3 and 4. Does that mean we can just disregard that? Not really. Security is not really a product that you can just patch and that's it. Security is a process. You need to continuously over and over and over assess it. We've heard and spoken with lots of manufacturers and users over the past year or 2 years. And surprisingly, we heard quite a bit about, yes, we're using VPNs, so we can just relax about security, right? Well, here I brought to you actually a CVE, which is a vulnerability identifier, which came up just a few days ago. This is a hole in VPNs, which applies actually across vendors, OpenVPN or other implementations. And it does apply to Linux and other operating systems. So this means that regardless of whether you deploy a VPN per robot or per series of robots or even per robot component, you're subject to be vulnerable. Once again, security is a process. What my team and I do is to get ourselves in the mind of an attacker. We try to provide security offensively. We don't provide the mitigations. We report about the vulnerabilities. Now, this is the pipeline of what we believe and are applying happens when an attacker attacks potentially a robotic application. It goes from reconnaissance, which is a topic we covered at last ROSCON. We gave a speech at the security workshop, pretty much showing how ROS2 was vulnerable to some reconnaissance attacks at that point, down to control. Because in robotics, we don't care just about exfiltration of data as it happens in IT. We also care about losing control or having our robot controlled by a third party. That's likely the last scenario. Today, we'd like to give a few bits about cyber intrusion, exploitation, and particularly, we'd like to discuss a few points that we've learned so far about vulnerabilities. Now, from a security perspective, we wanted to bring you some definitions. Bugs are errors, failures in software. So typically, most of those errors we see out there are bugs. Some of them are quality related, some of them are security related, and there are even others. The ones that have or might have security repercussions typically are denominated as weaknesses. Now, if a weakness is exploitable, right, if a malicious actor or actress can directly use it for bad purposes, then it becomes a vulnerability. It elevates 1 degree. Vulnerabilities are in charge of most of the bad actions we see in industry, across industries actually. But within vulnerabilities, we have a subset that's specifically worrying. And that's where we should probably dedicate short-term and also long-term, frankly speaking, most of our resources. And those are 0 days. Vulnerabilities that haven't yet been patched or mitigated by those that should be interested, typically manufacturers, of course also end users, but it's up to the manufacturers to react. Alias Robotics' motto is actually to remove 0 days from robotics, and it's exactly because of the relevance of this aspect here. Now, we wanted to bring to you here some information that actually in the next slide you will see it's open and everyone can see it, about the data we have collected over, specifically this has been cooked not so long ago, recently, about ROS, ROS2, and 2 vendors, UR, which is here today with us, and ABB. So let's start with ROS, right? So, and you have two graphs here that compare very different things, yet correlated and interesting at the same time. We have days until mitigation of a flaw, vulnerabilities in this case, and then we have the proportion of 0 days. Which one of these vulnerabilities have been patched and thereby are mitigated, and which one of which proportion remains as a 0 day. If we look at ROS, we see that there are vulnerabilities that are longer or older in this case than 3 years, and in a way that matches with what many of us believe, right? ROS 1 was not thought for security. Yet we see there's been some patches, some security patches, and some vulnerabilities have been mitigated. If we look at ROS 2 and we only take into account the days until mitigation, we say, well, vulnerabilities are below the 2-year barrier, so it's doing better than ROS 1, right? Well, no. All of those are actually 0 days. Most of them, I must say, though, apply currently to the DDS layer and are pretty much related to aspects of the standard itself. The standard itself has flaws. We have discussed this with several vendors, and we are trying to work out a way to somehow tackle this. If we go beyond ROS and ROS 2 and look at some of the most popular and acknowledged manufacturers, we have UR, for example, which has vulnerabilities reported more than 2 years ago, getting close to the 3rd year, which remains still as 0 days. And we have ABB. ABB has some outliers up there, which indeed show there's a lot to do still in security, but you can see most of the vulnerabilities are actually concentrated within this line, which represents half a year. That clearly shows that they are doing something about security, that they are submitting and filing advisories, that they are dedicated resources. And anyone, which actually, all of you can do it, that Googles it around, you will see that ABB submits and files advisories very actively. As I pointed out, this data is actually online and available. We're constantly updating it, constantly. There's a lot of work to do, and we encourage everyone interested in security to help us do it. We denominated Robot Vulnerability Database, and of course, this is a biased data set or archive because we cannot really cover all of them. There's constantly new vulnerabilities applying to robotic technologies going on, and also biased in the sense that not all of the vulnerabilities are here. First of all, because we don't disclose everything we find to try to be responsible with manufacturers first. So in that sense, we're very open to contributions, but still this already shows very interesting aspects. We have a total of 102 vulnerabilities cataloged that apply to different robotic technologies. You can go to this repo and check it. With that data, and trying to remain still very humble with this biased data, we plotted these two things which already show interesting conclusions. Essentially, the first one is that there's no security, or security by obscurity doesn't work. If you try to hide into a corner and essentially ignore security, it's going to be obvious based on data, and we can see it here in some of these cases. The second one is that investing, putting resources in security correlates directly with the spread of its criticality. As you commit yourself to security, involve yourself with more and more security teams, in-house or outside of it, you see how more and more vulnerabilities of different criticality are being filed and mitigated. And also, we can somehow conclude how, in a way, dedicating resources and budget into security correlates to the amount of vulnerabilities filed, which also correlates with the maturity of a product. Without getting into details of of how many, because we're still, as I said, processing data, and there's many that will come into our list, we wanted to give you a sense of intuition of where exactly are we categorizing vulnerabilities for ROS and ROS 2, and we are using here standards that are widely spread in security, in particular CWE, the Common Weakness Enumeration. And one observation we take from this is that the vulnerabilities that essentially appeared and keep appearing in ROS are slightly different from the ones in ROS 2. And this, well, essentially relates to the middleware that sits just below ROS 2. So here we wanted to give you a sense of intuition of how we actually operate. And we are here proposing a scenario where essentially there are two subjects of study, both of them using a UR robot with ROS-2, one of them using SROS-2, which, as most of you may know, is the secure ROS-2 packages, right? And so we would expect that a malicious attacker with access to the local network where the worker is connecting would be able to perform reconnaissance on the robot that's essentially not protected and using a ROS-2. But reality is different. We filed actually about a week ago this vulnerability, which essentially shows how an attacker can perform reconnaissance and obtain information about the nodes in the network, even with SROS-2. This is something we're currently looking at. So even ROS-2 currently has issues. We've put lots of resources into trying to help, trying to reach mitigation as soon as possible. And for that, we have been creating something kind of like a toolbox we call Uriarte, which allows us with simple YAML representations create subjects. So in this case, this is the YAML file for this particular scenario. Uriarte, again, our toolbox, which allows us to help secure systems. It's based in Docker. We're trying not to reinvent the wheel. Every single module is a piece of software that abstracts an element that's relevant for a robotics application. We have robot components, we have robots, and by robots we typically mean their file system image when visible, or direct connectors to the real physical mechanics of the robot. We have forensics tools, exploitation tools such as Metasploit or Robosploit, which we will hope to release very soon. Testing tools for doing static and dynamic testing. Also, we have fast testing elements, which we are open sourcing very, very actively, reconnaissance elements. And of course, of course, we are also making use of the great tooling that the ROS and the Gesivo community provide for our security assessments. Uriarte allows us to, once again, prototype very quickly, because as, well, I guess most of us facing robotics know, system integration takes lots of time, so simplifying that aspect when it comes to security really speeds up assessments. So with really this YAML, we can launch and put together cook subjects like this one, which in this case, for example, include the black box tools, which is our own implementation for forensics, data recording. We can build setups that connect the attacker and the subject in not networks, surround them with VPNs, VXLANs, lots of different networking technologies that simulate real and realistic scenarios. We can even go very, very, well, not complex, but more elaborated, and build things that get reasonably close to some of the study cases we are working with clients in real industries. Let me share with you one of the use cases we recently put together in actually a matter of a few weeks. We built this thing that you will see in about 2 weeks. So if we did it in 2 weeks, malicious attackers can certainly do it. Plus, the technical complexity of building this up is really not high. And I'm happy, or unhappy, I don't know what I must say, to present likely, and as far as we know, the first instance of robot ransomware applied on an industrial robot. And I'm going to switch, apologies for this. We had to split things up to the first video. Okay. So in this case, this is not the video? Okay, let me change. Okay, so this is not it, certainly. But you will have fun soon. Okay, so we copied the same one, unfortunately, so I'm going to try to real quick access, and maybe you can help me.
Video one is here. This is video one.
Did you press on it? Oh, there we go. That's it, that's it. Solved. So this is a video that shows the ransomware attack. So what we're seeing over here is how essentially an operator is using the UR robot with the teach pendant. This is happening every day. in thousands of places, right? And suddenly, in a purposed or unpurposed manner, a worker connects a stick that unfortunately contains this piece of ransomware, right? And what's going to happen is going to be real fun, which is essentially that the robot, by simply connecting this, is going to get stopped, where essentially, and I'm going to stop here, actually, so that we all can appreciate it. It's okay. So we stop the robot, we encrypt the file system and all of the tasks, we disable safety, and furthermore, we ask for a Christmas present. So this is surprisingly, and as I pointed out, something we cooked in a really, really short term. Of course, this is not going to get into the public ever, but the fact that we managed to do this so easily means that there's lots of work to do on our end, and also means that many, many more complex features, attacks could be essentially enabled. Things such as disabling certain aspects that essentially conflict with safety, things such as iteratively making a particular brand look worse than they are actually, and as complex and as bad as your imagination can get. I'm going to get back to the slides are this one, I think. Yeah. Okay, so that's robot ransomware. Let me actually get you a bit on context of what this means. We performed, as I said, this in a reasonably short time, and we went from 5 public vulnerabilities that we found for the UR3 robot, 5 that were published in 2000, I think 16, 17 by IOActive, a collaborator we've worked in the past, a company doing security. These 5, as I said, are 0 days, they haven't been patched, no reaction has happened for a year. We went from 5 to more than 300, and by the way, we are still counting. 300 vulnerabilities. We really, really need to react. I think a previous speaker said that we're trying to scare people here. Well, the situation is scary. The situation is really, really scary. It's time to react on this now. And furthermore, point is that there are opportunities right now. There are several companies, us being one of them, trying to help a variety of different, as I said, manufacturers and users. So if I am one of those, what can I do? Well, the first 2 advices that we have is A, threat model. That means understand your attack surface, understand your attack vectors. You should really do that. Hopefully you do it before you start designing or building a robot, but if not, you can also do it afterwards. It's never too late. The second one is once you understand your threat landscape, pen test. Do penetration testing, exactly what we did and what I'm showing here. It is not too late in robotics, and we certainly have time. Hopefully that's something my colleague can catch up with.
Do not panic. Alias Robotics is here to help. So it is our pleasure to introduce you our defensive products. Some of you may know us because of our forensics and traceability-oriented black box, which Víctor was mentioning before. But today, it is my pleasure to introduce you RIS, the Robot Immune System. This is a security monitoring software that integrates perfectly with each of your robots. In this case, what we are presenting here is the solution that UR is requiring. So we're basically offering a hardening and a mitigation on top of very well-known vulnerabilities in universal robots that provides also an alert and preventing system. So it becomes fully integrated with your UR Teach pendant, so the operator is able to see live what the status of the robot is, what the actual threat landscape looks like, and receive in real-time alerts and notifications. So we can do several things with our RIS. In this case, you have a button here that shows the overall status, and it becomes red when there's a danger or an alert coming, and you can receive a pop-up of the alerts just when you press on information, and you can receive these kind of alerts anytime when you are operating the system. So you get this insight on the actual security status if some attacker is trying to exploit vulnerabilities in your UR. So it is our pleasure also to show a live video of this. We'll have to switch to video to MP4. So again, we took the role of the attacker to POC two attacks. In this case, the first attack that you will see is using the network attack vector. So the hacker is able to connect to the robot, and just by launching some malicious commands, the robot is left like a pretty good paperweight. So the system will reboot, and then we'll try a second attack, which is basically exploiting a physical attack vector again. So this is very similar attack to a Kerberos, in this case, the ransomware you've seen, when we basically, again, leave the UR3 as a really nice statue that you can keep for the posterity. So this is the way that you install ROS. It's as simple as plug and play, and it immediately acts and patches some security vulnerabilities, hardens some others, and enables this monitoring system within your robot. So you see there, we fix vulnerabilities, then we provide a UR cap that the robot end user is able to manipulate, is able to notify pop-ups in real time. It's very easy to use, and with ROS, the attacks look like this. So the hacker is trying a really nice script, and we get a warning signal. A dangerous action has been performed. We get a notification of this. After that, we solve it, and then we try the second attack. The very same, the physical attack vector. And in this case, we're trying to exploit a vulnerability that would render the system useless. In this case, we prevent it immediately. So we get the malicious threat prevented message, and the operator, again, is able to resolve and to go back to normal operation. This is ensuring full availability of the robotic system. Availability is critical in industrial domains. Sorry. Thank you, Víctor. So this ROS adds immediate value on top of Universal Robots in this case, which is a very particular vendor in the landscape, but we've been in conversation with some other vendors out there. And I have to say that the security landscape that we've seen on the manufacturer side doesn't look very promising. So this was the main motivation for our robot security survey. In essence, the robot security survey wanted to assess the whole value chain in robotics for the security concerns. And this happened because we constantly received inputs from the manufacturers from, let's say, three categories. We had the security-aware players that are the fewer, I have to say. Then we have the security agnostics that immediately refer back to some other things, such as, I don't know what security means, such as safety or some other weird, let's say, answers. And then we have the knowingly players that do not care at all about security and directly blame it to the end user. This is summarized in some distinguished robot manufacturer quotes that we would like to share with you. So, for example, when inquired about security, they refer immediately to the safety pitch. Some of the really weird claims on the agnostic side that they say that basically cybersecurity flaws greatly facilitate system integration. And some very odd claims as well that just attribute these fixing or mitigating capabilities to the end user. So vulnerabilities are up to the end user in some manufacturer's opinion. And just some extra claims that advocate for evitating connecting your robot. So this is the main mitigation strategy. Isolate it as much as you can. Some of the claims include the fact that, well, yeah, it noted, but 3 months later, it cannot be fixed. We couldn't fix it. We need extra assistance. Well, our conclusion then is that the cybersecurity is something that the robot user needs to care about. If the robot user is malicious, then we say that cybersecurity is up to the hacker. So that's why we performed this robot security survey. Alias Robotics, together with Joan M. Research, Bernard Divers sitting today in the audience. Thanks very much, by the way, some community members that helped circulate this robot security survey, Thilo in particular. So the overall objective is to depict accurately the global security landscape in robotics. So for that, we wanted to assess the concerns of the rest of the value chain. We knew a little bit about the manufacturers. What about the rest of the players? What about the end user? So that's why we structured the survey as follows. We asked some sort of general questions, and we dive then into usage and cybersecurity and standardization items. For the purpose of this talk, I will be introducing some of the main conclusions that we've drawn out of the data in cybersecurity. So at the time of writing, we had 43 responses with very different backgrounds and profiles. So we had some robot manufacturers, university respondents, end users, software component manufacturers, integration, all kind of backgrounds in there from the industry, and with very different positions. So we have the most of them coming from R&D and software engineering phase, but we also have some management positions, such as CTOs and CEOs, and not that technical profiles, such as sales and marketing. So this is some of the observations that we've drawn out of this survey. So when we asked the respondents if they had identified vulnerabilities in the robots, 51% of them said yes. They had identified cyber weaknesses in the robots. Note that some of these profiles were not technical at all. But the good news is that only 9% have witnessed a cyber attack. So this is good news. Cybersecurity breaches are not yet mainstream. We are at the moment of taking action. Now, when we inquired these players about the actual vulnerabilities that they observed, they were all coincidentally mentioning the exposed network services as the main point of potential vulnerabilities, then potential physical attacks, and issues in proprietary firmware, in this case, were coming third. Now, when we asked respondents about their fears when it came to a cyber attack, they feared the most intellectual property rights stealing or industrial property rights stealing. But second, safety violations were a concern. Now, when we asked about the likelihood of these outcomes to be happening, the safety violation came first and the data loss came second, which is somehow intriguing, and this the mentality that security indeed is a prerequisite for this safety. Now, when we asked about the malicious actors to be performing these attacks, hackers came first, obviously, but second, unintentional employees came. So this is employees not knowingly and knowingly performing some, not always cyber attacks, but maybe misuse. Third were intentional employees, insiders, that were trying to manipulate these robots from the inside, introducing micro defects or others. Now, security perception has gained relevance. 8 out of 10 was the rating that respondents were attributing, whereas the actual perception of robot protected as an endpoint was 2.2 out of 10. And this varies when we unstack all the analysis with all the players in the value chain. So large enterprises have, let's say, a higher consideration for robots protected as an endpoint when it goes down back to universities. When we ask about security relevance, there's a similar curve with an RTOs performing lower, but overall university respondents attributes the highest score to security relevance. What happens when it comes to economics? So it is important to know the economic side of security. Security is a process, not a product. You have to invest on it all the way. 73% of the respondents were open to invest. 26% have actually invested. There's a massive gap. When we asked about the fact that they thought that they had invested enough, we get the same figure, 73% thought that they had not invested enough. Again, the survey is still on. Ping me later if you wish to participate. I can provide you a pointer. We are still gathering data. We'd love to gather some more data of all the players and to express some of your concerns, or not, on top of security. But this is a callback for action. It's not too late. Roger said it before. It's day one for robotics. We should take action now, and this is now the very dawn of robotics. Let's take the lessons that were not learned from other industries in IT. This is time to raise hands and to dive into all the security process. Security by obscurity does not work. Security needs to be built since the very beginning in the life cycle. Let's do that now. We are here to help. Alias Robotics is your robot cybersecurity partner, and we are committed to eliminate 0 days in robotics. Thanks very much.
Okay. Thank you for the talk. So we have maybe time for 1 or 2 questions. And this is probably a topic which I would expect some. It's not the case. Okay, then we move on with the next presentation.
We'll have a dinner discussion on this.
Of course.
And before that, I still take a few.
Okay. So next presentation is analytics for autonomous driving, and the speaker is Jan Wiegemann. Please.
Hello, welcome. So thanks for having me. Thanks for the pointer. So my talk is about autonomous driving, and it's mainly focused on data. So we heard a lot of talk today about code and code quality and security and so on.